Hello everyone, let us start with the earlier example. In the last lecture we have seen this example. We have to find out the rate of change of phi, that is directional derivative phi, in the direction of the normal to the surface at this particular point. Now normal to the surface we have calculated here del phi 1, it is normal to the surface phi 1, it is a theoretical part. We have to calculate del phi 1 first. Now del phi 1 is, by definition, it is the answer for del phi 1 is this. The last lecture we have seen till this step. Now we have to put the point here 1 1 1. Now by putting this point in this del phi 1, del phi 1 is equal to 3i plus 4j plus 2k. Now del phi is nothing but delta phi by delta xi plus delta phi by delta yj plus delta phi by delta zk. Now taking derivative of phi with respect to x, y and z and write down here, we get this del phi. Now from equation number 1, this is equation number 1, this is a formula. Rate of change of phi is nothing but directional derivative of phi in the direction of normal to the surface del, that is del phi 1. Therefore it is given by del phi into in the direction of this vector divided by its magnitude. Okay, now this vector is 3i plus 4j plus 2k and del phi is this. The point is not given, point is given only for the phi 1, not for the both. Okay, therefore we are keeping this del phi as it is here, and point 111 it is given specific for phi 1, that's why we have put this point in this phi 1 only to calculate this del phi 1. Now this is the definition of directional derivative. We know because this is a formula for directional derivative. We have seen directional derivative of phi in the direction of any vector a bar is nothing but del phi into a bar upon mod of a bar. Now here we have to calculate directional derivative of phi in the direction of del phi 1. That's why instead of a bar here del phi 1 we have to replace. Okay, this is a definition of basic definition of directional derivative. Now this is the numerator, this is the denominator. Denominator is under root 29 and numerator it is one vector ijk into this is other vector, this is again ijk. Therefore it is a vector multiplication, dot product. And dot product, how we take the dot product of two vector? By multiplying the corresponding ijk coefficient, that is 3 into yz plus 4 into xz plus 2 into xy, and go on adding those things. Ijk gets cancelled here. Okay, or I into I becomes I square, and by the unit vector definition I square becomes 1. This is the answer for rate of change of this phi. These are some homeworks for you. This is the, we have to find angle between the normal to the surface. This is one surface, call it as phi 1. Hint, first call it phi 1, phi is equal to xy minus z square. Okay, and we have to find out angle between two normals. Normal means we would then find out del phi. Okay, and put the point first 1 4 2 and then minus 3 minus 3 3. We get two vectors, called first vector as a bar, second vector as b bar, and use the formula, that is cos of theta between two vectors is a bar dot b bar upon mod of a bar into mod of b bar. We have already seen such type of example. This is a homework. Answer is cos theta is equal to 1 upon 222. Next homework is find divergence and curl of f bar, where f bar is given like this. It is xyzi plus 3x square yj plus xz square minus y square z into k. We have to find out curl and divergence. Del f bar, del cross f bar. Tally this answer. Answer for this second one is 0. Okay. Now next question is, we have to prove curl of r bar cross a bar cross b bar is equal to b bar cross a bar, where a bar and b bar are constant vectors, and we know A bar and B bar constant vector where this is homework, but before that hint is A bar is constant A1I plus A2J plus A3K. B bar is B1I plus B2J plus B3K. And R bar we know it is a position vector xi, it is not a constant, yj plus zk. Okay, take this LHS then RHS and so that they are equal. And we are going to see this example, and by solving this after this example we can solve easily this example also. Okay, let us move this one. Phi 1 is x plus y plus z, phi 2 is x plus y, phi 3 is minus, take this minus inside, minus 2xz minus 2yz minus z square. Prove that del phi 1 dot del phi 2 cross del phi 3 is equal to 0. First find out del phi 1, del phi 2, del phi 3. First take this bracket del phi 2 cross del phi 3, cross product of these two. Then take dot product of these two, and so that this is 0. Okay, so homework. Now let us see these examples. If A bar and B bar are constant vectors and R bar is a position vector, then prove that del cross A bar cross B bar cross R bar is equal to A bar cross B bar. Del dot R bar dot A bar cross B bar is equal to A bar cross B bar. Del dot B bar dot R bar dot A bar is equal to A bar cross A bar dot B bar. Remember, dot product is commutative. That is A bar dot B bar is nothing but B bar dot A bar. We can write anyway, any one of the way. But A bar cross B bar is not equal to B bar cross A bar. It is reverse. A bar cross B bar is sign gets changed. B bar cross A bar. Okay. So that dot product we can write down as it is or in any way. But cross product, while writing cross product, we have to take care of the sign or the position. Now let us prove the first, and let us prove the last one, and you have to just take this homework. After solving these two you will solve easily this one and the earlier one also, this one also. Okay, now let us start. First we have to find out the bracket terms. Let define first. A bar is equal to A1I plus A2J plus A3K. B bar is equal to B1I plus B2J plus B3K with the constant vectors. These are constant vectors. Means what? A1, A2, A3, B1, B2, B3 are constants. Okay. And R bar we know is a position vector. Xi plus Yj plus Zk. And XYZ are not constant. These are functions of XYZ. Okay. Now first calculate B bar cross A bar. B bar cross A bar is a cross product of two vector. What is the definition? First it is a determinant 3 by 3 determinant. First row is ijk. Second row, first row's coefficient. First vector's coefficient b1, b2, b3. Third row R bar's coefficient x, y, z. Ijk coefficient. Now solve this. I into b2z minus b3y. Middle sign is minus j. b1z minus b3x plus last k b1y minus b2x. This is B bar cross R bar done. Now take the cross product of A bar. Therefore A bar cross B bar cross R bar is equal to, again this is a cross product, that means 3 by 3 determinant. First row is ijk. Second row, first row vectors coefficient, that is a1, a2, a3. And third row B bar cross R bar's ijk coefficient. I coefficient is this here. J coefficient, it is minus sign here, that's why just reverse the term b3x minus b1z. And last k coefficient here. Now solve this again. I into a2 into this minus a3 into this. It is minus already, that's why it becomes minus minus plus. Second term minus j, a1 into this minus a3 into this. It is already minus, minus minus becomes plus. This one term becomes minus. Now k into a1 into this minus a2 into this. Okay, nothing is common, nothing we can solve further, that's why keep that as it is. Now last step is take the cross product of del. Now del cross A bar cross B bar cross R bar is equal to, first row again it is a cross product, therefore it is 3 by 3 determinant I, j, k, first row. Second row, first vectors I, j, k coefficient. First vector is del. We know del is nothing but del is nothing but deb of deb by x I, deb of deb by y j, deb of deb by z k. Therefore, I, j, k coefficients are derivatives. Therefore, second row is deb of deb by x, deb of deb by y, and deb of deb by z. First row is I, j, k coefficient. Third row is this total vectors I, j, k coefficient. These are the I, j, k coefficients where this is I coefficient here, okay, up to this. J coefficient, it is already minus, therefore we have to change all the signs. Take the first positive one, a1 b2 x, this should be minus a1 b1 y, this should be plus a3 b2 z, this should be minus a3 b3 y. J coefficient, and k coefficient as it is right down here. Okay, now we have to solve this determinant and we have to prove that this is a bar cross a bar. Now consider I into this cross this, derivative of this term with respect to y. Where is y? Here is only y. Therefore, the rest of the terms are constant. A, B, C are already constants, and with respect to y, x and z are also constant. Therefore, derivative of first three terms are 0. Only y present here. Therefore, derivative of this is a2 b3 minus this derivative of this with respect to z. Z is available here only a3 b2 minus middle sign j, derivative of this with respect to x. X present here only, therefore a1 b3. Rest of the terms derivative is 0 because they are constants. Minus this into this, derivative of this with respect to z. Z is available here only a3 b1. Plus now k, this into this, derivative of this with respect to x is a1 b2 minus derivative of this with respect to y, it is a2 b1. Okay, now call this equation number 1. We have solved this LHS. Now we have to solve this a bar cross b bar. Now a bar cross b bar is again a cross product, 3 by 3 determinant I, j, k. First row, second row a bar coefficient a1 a2 a3, third row b bar coefficient b1 b2 b3. First row is I into now a2 b3 minus a3 b2 minus middle sign j, a1 b3 minus a3 b1 plus k, a1 b2 minus a2 b1. If you consider this one with this, these are same. Okay, therefore from 1 and 2, this LHS is equal to this LHS is a bar cross r bar. These are very easy examples. Now consider third. Second is your homework. Third, consider b bar cross. First we have to find out, this is the second, take this as a homework. It's very easy. Now third, we have to find out first b bar cross, b bar dot r bar, then dot with a bar, then this del, and we have to show that it is a bar dot r bar, b bar. B bar dot a bar dot product of two vector b1 I plus b2 j plus b3 k dot xi plus yj plus zk. It is corresponding ijk coefficient should be multiplied b1x plus b2y plus b3 z. Now b bar dot r bar dot a bar. This is b bar as it is. This is dot a bar. Now this is not a vector because ijk is not there. This is a vector, and this is only function. And this function multiplied to the vector. How we multiply? Just multiplying to the inside the bracket. Therefore a1 into this I plus a2 into this j plus a3 into this k. Okay, this is now vector because I, j, k are there. Now again take del dot of this. Calculate, write down first del. This is del dot with this. This is this. This is the above function, above vector. Now how we take this? This is one vector and this is also a vector. Now how we take derivative multiplication of two vector, corresponding ijk coefficient should be multiplied. Deb of deb x of this I plus deb of y of this j plus dabba z of this k. Okay, now take this derivative of this with respect to x present here only, it is a1 b1 plus derivative of this with respect to y, that is a2 b2, derivative of this with respect to z, that is b3 into a3. Okay, this is LHS side of this, prove that term, call that as equation 1. Now RHS is a bar dot b bar, and we have to show that this equation is equal to a bar dot b bar. Write down a bar, this is dot b bar, this is dot product of two vectors, corresponding ijk should be multiply a1 b1 plus a2 b2 plus a3 b3. If you observe these two, these are same. Therefore LHS from 1 and 2, LHS is equal to RHS. These are some vector identities. DIV means divergence. Sometimes a capital D also use in examples. Divergence of phi into u bar. Bar means vector, and without bar whatever phi, psi, they are functions, and a, b, c, they are constant vectors. Divergence of phi dot or dot, see, cross, if cross product is there, then cross product should be written. If dot product is there, a dot product should not, no need to write the dot between these two vectors, because it is like if you multiply anything by 1, we don't write 1. Okay, it is self understood that there exists 1, like that only. Here dot is not there, but still it is a dot product of this one function into one vector. Okay, now divergence of this two means del dot phi u bar, which is equal to phi is nothing but it is like u into v rule, u into del of u bar, phi as it is del of u bar plus del of phi u bar as it is. This is u into like u into v rule. Now curl of phi dot u bar is equal to del, curl means del cross of phi of u bar. It is a divergence means del dot, curl means del cross. Okay, now how we calculate this? Del phi as it is del cross u bar plus del cross phi, del phi cross this u bar as it is, del phi cross u bar. Now third identity is divergence of u bar cross v bar. It is a cross product of two vectors. These are totally two vectors. It is, that is del, divergence means del dot of this term. Now it is written as v bar dot del cross v u bar minus u bar dot del cross v bar. Now gradient of u bar v bar into v bar. Gradient is also nothing but is del dot of these two scalar. The product of two vector is a scalar. U bar dot v bar is nothing but u bar del cross v bar plus v bar cross del cross u bar plus u bar dot del into v bar plus v bar dot del into u bar. These are some identities or formulas. Let us prove some identities also here. Higher order derivative of del. Prove that del square of phi psi is equal to phi del square psi plus 2 del phi del psi plus psi del square phi. Second one, del phi del psi minus psi del phi is equal to phi del square phi psi minus psi del square phi. Now let us see how to find how to prove that. Del square, consider LHS. Del square phi psi is equal to del square means del into del, phi into psi. Now apply first del on this product using this formula divergence. Then u into v rule, that is del into phi as it is del psi plus psi as it is del phi. Now again take this del inside, del of this term plus del of this term. Now again u into v rule, phi as it is del of phi psi plus del of phi into del of psi as it is, plus again apply del of on this product, del phi as it is del of psi plus del of phi multiply by psi as it is. Now if you observe, these two are same terms. Okay, therefore it becomes 2 times del phi del psi, and this becomes del into del, that is del square. Here also del into del square, which is the this term same, hence proof. Now second term, second is also same, These are some steps. Here in second, this term gets cancelled. That's why we get this term. Okay. Now let us consider this. We have seen the vector derivative. Now we are going to see the vector integration, that is integral calculus. First consider the line integral, how to solve the integration along the curve, where f bar dr is in other theoretical word f bar dr bar here is nothing but the total work done. Suppose a particle is moving in a plane with a particular speed, then total work done by that particle is nothing but f bar dot dr bar, and it is given by fx dx plus fy dy plus fx fz dz, which is already given in the example. Okay, now first let us consider line integral example directly. Let f bar is given as x square I plus xyz. Find integration of f bar d bar over the curve C, where this curve, first example, where the curve C is nothing but y square is equal to x joining 2.0011, and in second case C curve is y is equal to x joining the points 0, 0 and 1, 1. First consider first curve, write down the equation of curve y square is equal to x as it is. Now take the derivative like in the integration by substitution. In the substitution method we put one particular function, and for that we take the derivative on both sides. Similar in that way, this is the substitution, like this substitution, y square is equal to x. Now take the derivative on both sides, we get y square derivative 2y into dy is equal to x derivative dx. Okay, now here comparing, this is f bar, comparing this with this is we have call it as I coefficient as fx, j coefficient as fy, and k coefficient which is absent here, that means fz is equal to 0. This is an important step. Okay, these are the only important step. Rest of the thing we are just calculating the integration by substituting the values. Okay, now consider this integration over f bar dr over the f bar dr bar over the curve C, first curve. Now over the curve C, f bar, put the value of f bar by our theory. F bar dr bar is fx dx plus fy dy plus fz dz. Now put the value of fx, fy, fz here. Okay, we get this term. Now in this case either we have two options, because we have to check whether the integration over the C means you can convert all the equation in x, or you can convert all the equation this integrand inside the integral function in y. In both the way answer should be same. First for our convenience we convert all the terms in x. Okay, for that keep this x as it is, because it doesn't contain any other variable. First here y dy becomes dx by 2. Okay, and 0, it is 0. Okay, now whole the thing convert into x, there is no any other variable, therefore we have to take the limit of x, and these are the joining points where first coordinate is x coordinate, second coordinate is y coordinate. That's why it is lower limit is 0, upper limit is 1. Okay, therefore this is 0 to 1, this is as it is. Now this is very easy integration. X square derivative is x cube by 3 plus 1 by 2 as it is. X derivative is x square by 2. Limit 0 to 1 here. Now put the limit, we get 1 by 3 plus this 1 by 4. Answer is 7 by 12. Okay. Along the curve now second is y is equal to x. Take the derivative first, dy is equal to dx. Rest of the terms as it is, because function is same, fr is same. Now over the curve C becomes fx dx plus fy dy plus fz dz. Put the values as it is. Now x square dx as it is. Now x y dy becomes x square, because x as it is, y value is x here, that's why x into x becomes x square, and dy value becomes dx, it is dx as it is. This is 0, no need to write 0. Now x square dx becomes 2 times x square dx, and x square derivative integration is x cube by 3 from 0 to 1, because here also in the second curve x coordinate is 0 upper lower limit and y x coordinate of higher limit is 1. Okay, therefore x cube by 3 0 to 1 becomes 2 by 3. Now second, these are the homeworks for you. Find integration of f bar d bar over the curve C, where f bar is this along the curve. First, y square is equal to x, joining point 0 0 1 1. Answer is 2 by 3. Second is y is equal to x, same example, but f bar is different here. Here answer of two, both of them answer is same, 2 by 3. This is the homework for you. Now here next, f bar is equal to 3xy I minus y square j. Find integration of this f bar dr over the curve C, where curve is y is equal to 2x square from the point 0 0 to 1 2. His answer is minus 7 by 6. Okay, take the derivative, we get dy is equal to 4x dx. Either you convert x or in total y. Take the limit 0 to 1 if you convert in x, and take the limit 0 to 2 if you convert those variable in y. Answer is in the both the cases same, minus 7 by 6. Okay, now consider next. Find total work done. This is very important because it is given in the parametric form in terms of t. Find the total work done in moving particle in a force field given by f bar is given. Okay, and total work done is nothing but integration of f bar over the curve. It is a curve x is equal to t square plus 1, y is equal to 2t square, z is equal to t cube from the point t is equal to 1 to 2. That means the integration limit are 1 to 2, and integrand should be function of t only. Okay, and let us see. F bar is equal to this, keep that as it is. This is in the given in the example. First step is we have to put x y is equal to z is equal to in terms of t here. Therefore, putting the value of x y z here in terms of t and solving them, we get this f bar totally in terms of t. Once we convert this f bar into t, let us solve the integration. Now, total work done is given by integration of c over the f bar dr bar. Now we have to just multiply and divide by t, because our every function is in the function of t. Therefore, divide and multiply by t, we get this. Therefore, we have to find, for we know dt is with respect to t. Therefore, we have to find dr bar dt. Therefore, this is the one more additional step. Let r bar is a position vector xi plus yz plus zk. This is well known position vector. Then r bar is nothing but put the value of x, y, z in terms of t, which is given in the example. Then take derivative of r with respect to t. T square derivative is 2t. T square derivative is again 2t multiplied by 2, that is 4t. T cube derivative is 3t square. Okay. Now put these values, all these values here. This is total work done, means w is equal to integration over c, where this example is particular example of parameter example. Okay. Now the limits, lower limit is 1 to 2. This is given in the example of t. Now put the value of f bar, it is f bar into dr bar by dt is this into dt as it is. Now if you switch these two brackets, here izk is there, here also izk is there. That's why it is a dot product of two vectors. And how we calculate dot product of two vectors? By multiplying corresponding izk value. Therefore, this I coefficient into this I coefficient here, plus this I coefficient into this I coefficient, plus this I k coefficient plus the k coefficient. Izk get vanished into dt with respect to dt as it is. Now simplify this, we get this. Now take the integration over the t. T raised to 5 integration, t raised to 3 integration, t raised to 4, t square raised to 4 again, and t square. And put the limit 1 to 2. If you observe this, if you calculate this on calculator, the answer is 303. Okay, these are very easy steps. Now here one homework for you. Same example, just f bar is different. Find integration of f bar dr bar over c, where f bar is this and where c is given by x is equal to t, y is equal to t square, z is equal to t cube. From t is equal to 0 to 1. First put x, y, z value here. Simplify that. Then again find out dr bar. Write down this as it is in this example, where x, y, z values are given in already in the example. Take the derivative as it is and simplify like this only. The answer is 5. Okay. And one more example is here. F bar is 5xy minus 6x square I plus 2y minus 4xj. K is absent here. That means k is 0 or z is 0, z coefficient. Where c is the curve y is equal to x cube from the point 1, 1 to 2, 8. Okay. This is earlier example, earlier types example. Your answer is 35. Take the derivative on both sides. Convert all the equation in x or in y. If you convert this in x, take the limit 1 to 2. If you convert this in y, take the limit 1 to 8. In the both the cases, answer is 35 only. Okay. Solve it like earlier one.